Okay. I'm going to do my very best here to clarify the difference between distance, position, and displacement. Now, distance is certainly the first thing that you would learn, but it's actually I think, the trickiest to really understand. All three of these, the standard international units for all three of these, is the meter. So you can think of meter as a man taking a large step. That's how far a meter is. Now, you can also measure distance in kilometers, millimeters, centimeters, parsecs, light years, depending on the scale of what it is you're measuring. Okay, so imagine a snake slithers from point A to point B. And the question is, what is the distance that he has slithered? Now, the distance is a measure along the path. So we would have to stretch this out and determine how far it is that the head is actually moved along that curve. That's the distance. Now, one way you could estimate it is you could take a person, and a person could walk along that path, putting one foot along the path as they went. So as this person took a walk, we could count their steps, measure the length of each step, and add all those steps together. And that would give us the distance. However, the problem we run into when we do that is if we have a smaller person, they're not cutting off as much with each step as a larger person is. And therefore, they're going to give you a much different answer. So depending on the resolution, depending on how closely you look at this apparent distance can seem to change. However, to summarize that up, to clarify that idea, if you were to take that curve and stretch it out, that stretched out length is the distance that the snake has traveled. Okay, what was the position of the snake? Well, it started out at point A. It followed this snaking path, and it ended at point B. So there are two positions that we could be concerned with. We can't really answer this in an absolute way. We would need some reference point. So I'm going to put a reference point here and call it the origin. And if that's the origin, perhaps this is north, and if this is north, that could be east. So the original position of the snake may be, let's say this is 3 meters this way and 4 meters this way and 3 meters that way. So we could go 4 meters east and 3 meters north. And that's one way of describing position A. So A is 4 meters east and 3 meters north of the origin. Now there's an easier way to describe that. I could describe how far away we are from the origin and specify the angle within there. So position A is at a distance, which is the square root of 4 squared plus 3 squared. That's position A's distance. And that is 16 9 25, right? That's 5. So we're at a distance of 5 from the origin at an angle here, and our angle here above the horizon is arctan 0.75. Which is about 37 degrees. Which would make the angle up here about 53 degrees. So the position that the snake started at, position A, and we use the letter D to denote it. So position A is 5 meters. And if you start out north and you rotate 53 degrees towards the east, that's position A. That's where the snake started. So position B, to simplify things without calculating, let's just assume that we know. So if that's 5, position B is 20 meters. Sorry, out of the field of view here. Position B is 20 meters north, 53 degrees east. So that same snake, as it went from point A to point B, we had a distance, and that distance we would get by measuring the length of the curve after stretching it out. It had 2 positions. Position A, its initial position, which was 5 meters north, 53 degrees east of the origin. Now you need some reference point. That could be perhaps where you are, where you're observing the snake from. And that's how far away from you it started and in what direction. And we need both pieces of information to specify the position. The position is actually a vector. We put an arrow over that to indicate that it's a vector. And the final position is 20 meters north, 53 degrees east. So finally, what is the displacement? So the symbol for displacement is delta D. That delta means a change in, and displacement is the change in position. So we're going from point A to point B. That snake went through this path. Its initial position, we started out, position A was 5 meters north, 53 degrees east. And its final position was 20 meters north, 53 degrees east. The displacement is the change in position. So the displacement is the final position minus the initial position. Your displacement is a final position of 20 meters north, 53 degrees east. And from that, we're going to subtract our initial position of 5 meters north, 53 degrees east. Now, don't always think it's going to be this simple. I intentionally made both those positions at the same angle from our origin of reference. So I had it so that the initial position was 53 degrees east of north of the origin. And the final position was also 53 degrees east of north of the origin, meaning you start out north, rotate 53 degrees east, and you're looking both at position A and position B. Because they happen to be along the same line, and those angles are the same, and the compass references are the same, we can subtract these vectors with simple arithmetic. That will not always be the case. As soon as those angles are different, or those directions are different, you have to do vector addition to do the subtraction. Well, yeah, technically it's vector subtraction, but you reverse the second vector and you add them. So the displacement, which is the change in position, is 20 minus 15, it's 20 minus 5, so it is 15 meters north, 53 degrees east. The displacement is what you get when you subtract the final position from the initial position. It's a vector, meaning you must specify not only its magnitude, but also its direction. This vector can be drawn as an arrow. It's going to look like this. That arrow has a length of 15, and it has a direction that is 53 degrees towards the east if you start at north.